Hello everyone, welcome back to the channel. Today we are going to look into AWS Lambda. So AWS Lambda is basically a compute service. As we can see here, it's serverless. When we say serverless, as a user, you don't need to provision any instance or servers, right? So that is the advantage. The whole infrastructure internally is managed by AWS. You don't need to worry about the infrastructure. So that is serverless. No management from your side. That is completely handled by AWS. You just need to focus on the code and whatever you need to do in your basically you focus on the functional logic. Now let's understand what are the features of AWS Lambda. So the AWS Lambda, as we have understood, right? It's a compute service. You are going to write a code, it is going to get executed. So in terms of execution types, there could be two executions. Like one would be synchronous. So you will be calling your Lambda function, and basically till the execution is completed, the caller has to wait for the function to complete. So that's the synchronous, and maximum payload size is 6 MB. And asynchronous, it's like event based. So there are multiple event sources, and it just triggers the Lambda, and that's it. So the caller doesn't need to wait. So Lambda does the execution. There are options of retry with exponential backoff, and in this case, the payload size is 256 KB. And you even have the options of get data queue or any other figure destination. So that's the advantage. So these are the execution types of AWS Lambda. And as far as pricing is concerned, you pay only when it is being used. Say you create the Lambda function, but it was never invoked, so you never pay for that. But even for the invocations, if you look here, it is for first 1 million requests per month is free. So when we say 1 million, it's a huge number. So this is cumulative for all the Lambda functions that you create, but this is like huge number. And even after that, you pay like $0.001667 per GB second. Okay, so every computation is done based on the GB. Basically, it's 1 GB, 1 second, 1 GB. So that's the so like you can see 1 GB memory function running for 1 second equals to this much. So if you increase the memory, so based on that, your per second charges will increase. So that's the pricing part. Now let's understand the memory allocation or the important limits and quotas. See, when you execute Lambda, right, it needs some temp memory, or you could say RAM basically, not temp memory. Let's understand the RAM basically, any memories. So for the memory, it's the starting point is 128 MB. So basically, see, when you execute any application or any function, right, we need memory, right? Basically the RAM memory. So that RAM memory, or you could say that compute memory, which is required to execute the function. So the maximum limit of that is 10 GB, and it starts with 128 MB. So this is the RAM memory that it provides. The memory allocation step is 1 MB. Basically, the increments you can increment in 1 MB increments. The timeout basically. See, Lambda is not for applications or utilities or code which executes for say 3-4 hours, or it is a continuously running application. It is not for that. It is for smaller invocations, for the smaller time. When we say smaller time, the max timeout is 15 minutes, that is 900 seconds, and default is 3 seconds. So just keep this in mind. By default it is 3. You can change and make it like 15 minutes. And the package deployment size, right? The code basically. So it's 50 MB zipped, and unzipped code is 250 MB. And Lambda also provides option to run the container code or the Dockerized code. So that container image size can be up to 10 GB. That's a huge number. And in case of the temp storage, right, we need some temp storage. Like I might be reading some file, I might be creating some file, I might be writing in the some static variables, etc. So those would go into my temp storage. So those things, for that we have like another up to 10 GB. It is configurable, and by default it is 512 MB. And we even can pass environment variables. Then we even have layers, right? So when we say layers, like the common libraries, so your package size, your deployment package size, it's limited, right? And if you keep adding the libraries, your deployment package size would increase. So to handle that, you can create different kind of layers. So you, for every function you can have 5 layers, and maximum layer size is 50 MB. So that's the layering that Lambda provides. And the advantage of this layer is, say there are common libraries, right? And you have multiple functions, Lambda functions. So you can reuse those layers for other functions as well. So that's the advantage. Now coming to the concurrency part. See, when I'm executing a Lambda, right? Say I need, say, 10 invocations or 10 concurrent Lambda executions. So AWS does it internally, but for that your maximum concurrency, the limit by default is 1000. This is a soft limit. You can get it increased. And burst concurrency, again it varies by region. Burst concurrency means like say there is a burst of executions and scaling up that is required, and it can go up to 3000. It will vary by region. So just keep that in mind. And one more thing about concurrency is basically, see, if you have 10 functions, 10 Lambda functions, right? And all those 10 might be concurrently executing many Lambda functions, right? Or basically the instances, many Lambda instances. So it is cumulative per account basically. So if you are executing 10 and say one of the function is executing say 900 concurrent requests, okay, or you have 900 Lambda instances of that function running, then at that point in time only 100 would be available for the other 9. So just keep that in mind. It is not 1000 per Lambda function. It is 1000 per account. Okay. Then the synchronous payload and etc. And then as far as dead letter given on failure destination, we have options of simple queue service, simple notification service, Lambda, event bridge, other Lambda also, and result concurrency, like we have already concurrency we discussed, right? So this result concurrency is related to this concurrency, the number of instances that can execute, and provision concurrency, it's basically for your cold starts. Now let's understand what is the cold start. See what happens whenever Lambda executes or is invoked. So you need an execution environment, right? So AWS doesn't guarantee that it will be reusing the previous environment. So it will create a new execution environment. So if you create a new environment, then there will be a cold start. When we say cold start, that means it will first load all the runtimes, it will load the layers, all the configurations, etc., whatever is required, like database connection, etc., and all those stuff. That will happen. So you lose, or basically there is a lag or latency when you start the Lambda function, and then once the Lambda is ready for the execution, then it executes the code. So this is like kind of a deployment that you're doing. The deployment which is already deployed on an execution environment. So cold start relates to that. Now, say suppose I want a certain function to reuse the execution environment, then I can use this property of provision concurrency. So I can say like for a particular Lambda function, I want 10 execution environments. So AWS will provide or reuse the same execution environment. So every time it is invoked, the cold start is avoided, and the invocation is faster. So that's the advantage of provision concurrency. And as far as monitoring and logging is concerned, so it is directly integrated with CloudWatch logs, CloudWatch metrics, etc. X-ray also you can integrate it, and you can also set alarms or alerts on the metrics. And when we say event sources, so we have various event sources like S3 can trigger an event, API gateway can call a Lambda function, DynamoDB also can invoke a Lambda SQS. So these are the various event sources that we have. And like I told you, as far as auto scaling is concerned, it will auto scale as per your demand. And high availability, it is built-in tolerance. One more thing to keep in mind is Lambda is basically not attached to any VPC. It is outside of VPC, but you can attach to a VPC. So that is possible. And to execute Lambda, basically by any other event sources, they need to have the execute permissions on the Lambda. And similarly, if Lambda has to access any other AWS service, it would need the accesses basically of those resources. And deployment options, basically you can upload a zip file, etc. and the other options. So this is the theory part of the AWS Lambda. Let's look at the practical part using the AWS console. Here you can log into your AWS console. You will find something like this AWS Lambda, and you will find this page. There is option of create function, and once you click on that, so there are three options here. You can do it from scratch. Blueprint is basically whatever default which AWS has provided. You can use that. Then there is container image. This is for Dockerized application. We will go with this auto from scratch. Say my Lambda function. We use Python. For now, just ignore this part. These are the new features provided by AWS Lambda. We'll create the function now. So first we just provide the function name and the runtime. Just keep that in mind. As far as runtime is concerned, as far as runtime is concerned, you have a lot of options here. You can call Ruby, Python, Node.js. There are many options here. So you can use different runtimes. It supports a lot of runtimes. AWS Lambda. And once your function name is created, you would see this page basically. Here you have my Lambda function. Here there is a trigger basically. So in trigger, you have multiple options like API gateway, load balancer, CloudFront, S3, SQS, etc. So many options that can call Lambda. Cancel this. And as far as destination is concerned, so this is here on failure on success. You can send it as a notification to a SNS topic. You can put it in SQS queue, event bridge, event bus, and you can run even different Lambda function or put it into the S3 bucket. So, a lot of options as far as destination is concerned. We will not cover the trigger and destination in this lecture. We will cover in the other part. For now, we'll just look at a very simple example of Lambda function. So this is my Lambda function. Let me copy this one. If you look into this, I'm just setting the loggers here. Now, when we are calling the Lambda or invoking the Lambda, right? So every language has some important method names that should be there actually. So in case of Python, Lambda handler is required. So this is like your main method in Java, right? We need some main method. So similarly, AWS Lambda needs this Lambda handler. In Java, it is different. It is called as request handler. And this Lambda handler will have two parameters. One is event and the other is context. Now, what is event basically? Event is whatever you're passing as a payload. So those details will be passed as an event. Just keep this in mind. This is your request body, you could say, or your request payload. And what is context? When we say context is basically metadata about the lambda. Just keep this in mind. So it will have details like uh, what is the log string, what is the default timeout, or what is the execution timeout, and all those stuff. This is a very simple function here. We are reading the length and the width from the event. Like I told you, this is the request payload, and it is calculating the area. This is the method it is calling, and it prints. That's it. Once you paste the code, you call this deploying code. Now the code is deployed. Now to test it, either you can go here or you can go to this test, and we can create an event actually. This is a synchronous execution. So let's keep it test event for now and then synchronous. And I need these two parameters for my lambda function, length and the width, which you have seen in our code, right? Length and the width. That is what we are passing. Simple. This is just a test event, or you could say just a test case. So I can save it as well. Once I save it, you can edit also later on. Yeah. So my lambda function is executed. Now you can see here the details. The function version which was executed was $latest. Duration is 2.3 milliseconds. The resource is configured basically. The RAM you could say is 128 MB. Init duration, one which I told you, right? Before invocation, how much time did it take for the lambda function to initialize or basically complete the start, cold start? So it is 103 milliseconds. And execution time is 41 seconds. Sorry, it was 51 seconds ago. And you have the request ID as well. You can use it in your traces and build duration and maximum memory used. And see, this is connected to CloudWatch logs. Let's look into the CloudWatch logs. The Lambda function, what it will do is it will create a log string in the CloudWatch logs with the name of your function. So this is the name of my function, and in this folder, AWS Lambda. And if you see here, we'll take the latest one. These are the details here. This is the init time, the cold start time, you could say. Init start basically. Now it is starting the request. It is saying the version and the request ID. As you can see here, I printed this event. So this was my payload. This got printed here. And the context here. See what I told you about the context. It's the metadata of the lambda. Let me expand this and copy this in the notepad. As you can see, these are the details or these are the metadata that we find in the context. As you can see, there is a request ID, log group name, log stream name, then the function name, and what is the memory limit. I have set it as 128. That is by default. Function version, then invoke version details, ARN basically, any client context, etc. So this is your context details, and this is the output basically. And this is about the logs in the lambdas. Now look at, now I just want to show a version, right? What are versions basically? See, when I deploy my code, when I do some changes, right, and deploy my code, it gets deployed to a default $latest version. Okay, so Now suppose if I deploy this $latest version to production, and suppose someone does the changes on that Lambda function, and that dollar version will get deployed, $latest, sorry, will get deployed. Your unintended changes will go to production. So how do I make it immutable? So version is the answer for that, to make Lambda functions immutable. So let's see how we can do that. So you don't need to mention anything. You can just mention the description here. It will create the snapshot. Right? For this version, the configuration is set. Whatever you see here, it will remain as it is. Nothing will change for this version. So as you can see, my Lambda function :1. This is my version. Now, say suppose I add one more logger here. The editor is read only. You know why? Because this Lambda function is immutable, because it is version now. So that's the advantage. If I want to go back to my $latest version, I can just simply click on that version thing, and here I can see version 1. Now what I'll do is I'll just add another logger here, new version. Let me deploy this. It got deployed. If you want, you can test it out. It got executed successfully. Here you can see new version. Once this is done, let me create one more version. This is my version 2, new version. Again, this version is created. And if you want to go back to your $latest, you can go there. If I go here, come here. Now I can also create aliases. Now why do we need aliases? Let's understand from this example. I have V1, V2, V3. Alias points, alias 1, say these are aliases, man. Say it is prod. So in prod, I deployed V2, and my UAT has V2, and my dev has V3. Okay, let's understand in this way. So advantage of alias is, if you don't provide alias, and say you are calling your Lambda function from API gateway. So API gateway will say my Lambda function :V1. Now if I do this, and tomorrow if I want to promote this version V2, then in that case you will have to go to API gateway and change this one, which is not a good thing to do. So what we can do is, we can simply use the alias. Now if I want to promote this, say I want to promote V2, I just point my prod alias from V1 to V2. That's it. And this will execute V2. So that's the advantage of alias. Let me create this alias. Then create alias prod, and I give version 1. You even have the advantage of the traffic percentage that you want to divide. So this is basically canary deployment editing. Now your alias prod is now pointing to version 1. So that's the details about the alias and the versions. And you could say the basic details about the Lambda. We'll slowly cover the other details about the Lambda. This was the starting point. As you can see, we just created the code from the AWS console. We deployed it. We tested it using the test event. We monitored it using the CloudWatch logs. We created the aliases and the versions. And let me show you the option of provision concurrency. Here, these are the options of creating the provision concurrency. Just keep this in mind. Provision concurrency can only be created on version lambda. And I told you about the provision concurrency. This is just to avoid the cold starts. Thank you so much. Have a good day.